Welcome to the live steam build of Charles, the Penrhyn Quarry engine. This is being built to 1/12 scale to run on 45mm gauge track. The boiler is finished, apart from some tidying up. The back end is dark and oxidized from the repeated heatings. The front end is nice and bright. As with the quarry Hunslet, the hardest area to get watertight was the foundation ring, or the mud ring. Repeated heatings caused the silver braze to retract somewhat and holes form. The firehole opening had a perfect ring of braze around it, and now there is a small gap which weeps a tiny amount. And I've been very careful when reheating not to overheat. I braze in subdued lighting so that I can see the red heat. With the quarry Hunslet I only used one grade of braze throughout, and suffered a lot of remelting, causing water leaks. This boiler was a great challenge. I slowly plodded away at it without becoming disheartened. A harder grade of silver braze was used for the inner firebox and boiler barrel to firebox connection, the steam dome, boiler feed bushes, and smoke box tube plate regulator bush. A 35% silver braze. All the rest use a 45% silver braze. Copious amounts of silver braze was used, a sizable investment. Moving on to the construction. Here are some test pieces which I used to witness which grade of silver braze would actually melt first. Correction, the hardest grade used was 34% silver, and this was the last to melt. I tested it with 45% silver, with and without cadmium. I had both. I think with cadmium is the best, and I use this for all the final brazing. With the garage window open, of course. These pictures show how I worked the position of the regulator bush hole in the smoke box tube plate. It looked like 0.406 inches was the dimension to aim for. Bending the annealed 1.6mm copper sheet wrapper round the back head and throat plate. This was back in March. Holes were drilled for brass 10BA screws to hold the wrapper in place. The lower backhead screws became inadvertently brazed and were drilled out and replaced with copper rivets. The inner firebox components and then the assembled inner and outer fireboxes held together with brass screws. Here's my setup for fly cutting the bases of the outer firebox and then the inner. I made a hardened carbon steel cutter and mounted it in an M6 screw and screwed it into my aluminium faceplate. Here are the inner and outer firebox. They are connected by the thick firehole tube and are held together by the brass screws. You can see the position of the tube holes relative to the inner firebox and boiler barrel, and you can see how much space there is for steam. Just about to open up the regulator bush hole with a step drill. Regulator bush hole finished, along with the water gauge bush holes. The steam inlet manifold gets right in the way of the tubes, preventing them from being able to be swept. Another arrangement is needed. Mocking up the barrel with the firebox. With one tube in, I'm working out where the steam inlets will go. I'm thinking over the top of the tubes and around the sides. There's just enough room. I've just drilled the steam dome hole for the 1/4 inch hole saw pilot. Hole sawing complete. A piece of 3/4 inch ID water pipe makes up the steam dome. This is how I marked the position of the water feed boiler bushes on the boiler barrel. The firebox dome hole has been hole sawed too. Firebox components with its steam dome featuring 4 cross holes for steam takeoffs. The dome was turned from a piece of gunmetal bronze, but this threaded lid is 385 grade brass. The subtle colour differences are beautiful. I use this system on the quarry Hunslet. The large thread seals nicely with RTD sealant. The start of the regulator manifold and its bush in the smoke box tube plate. The first nipple on the steam manifold. I braze this using my thinnest 1/2 mm silver solder to prevent it filling the threads, although it can be cleared with a threading die. It's 3/16 by 40 TPI ME. This is how the manifold will work, with separate steam lines going to each cylinder dodging the tubes. The view down the funnel showing the manifold causing a bit of an obstruction. This caused me concern for drafting. I had to thin down the manifold and boiler bush to lose some of that obstruction. It took a bit of care. Here it is propped up with a piece of wire, much better. The start of the boiler brazing, using 34% silver braze, to have a higher melting point than that which I will use for the tubes and tube plate to boiler barrel joint. The 1.5 mm diameter brazing rod was applied directly during heating. There was good flow and penetration. It's always pleasing to be able to use up leftover pieces of material. Here's a piece of gunmetal, enough to make 2 small boiler bushes. Here's the second bush, tapped 3/16 by 40 TPI for the backhead. Carrying on with a smaller stick of gunmetal, 6 bushes of this size need making. Unfortunately, the upper right water gauge bush hole was out of position, a bit too much, and was easily seen due to the central regulator hole. I corrected it by filing it back to the correct position, then opening it up and fitting an oversized bush, the flange diameter being the same. I marked the correct position on a blanking plug. Then center punch the position on the blank. And scribe the position of the oversized hole on the backhead. This is where the hole should be. Set up for filing. File close enough to the line. Finish circular and to size with a 5/16 reamer. The 4 water gauge holes in the correct position. Backhead bronze bushes fitted. I forgot to turn a slight step on the firebox tube ends. The holes passed the tubes easily, so I grooved the tubes and rolled on enamelled copper electrical wire. I removed the enamel eventually. These wires stop the tubes from falling through the firebox, as the tubes will be brazed vertically. Just the right amount of protrusion was obtained for a good braze fillet. Here's a test braze of a piece of wire with enamel left on, wrapped around a piece of copper tube. The braze was good. Turning the large flange of the fusible plug bush. This large flange is a stiffener, so the inner firebox roof doesn't need staying. The stubby 1/4 inch by 40 TPI mandrel for facing the back of the bush. The bush sitting upside down on top of the firebox, and then fitted after drilling the hole for it. Also the incomplete fusible bush itself. It just needs filling with soft solder. The timber plug for turning the boiler barrel. The boiler barrel was grooved for a copper wire ring also. The start of the steam dome lid. A piece of 3/32 inch copper sheet was brazed to a mandrel for turning. The lid turned with a step to fit into the 3/4 inch water pipe used as a dome. I brazed the throat plate to the outer wrapper, the brass screws being replaced by copper rivets, not tightened, just to hold it vertically in place. Very untidy looking brazing. I use a 34% silver braze for this joint. Good coverage on the inside. I must have directly applied braze here. Those rivets are nicely covered. Here's the inner firebox all brazed up with 34% silver braze. Rivets nicely covered on the outside, where it matters. Lots of silver here. Perhaps the 34% doesn't flow as nicely as the higher grades. All exterior rivets were covered nicely. This is all run through braze. Nothing was applied internally. Trial fitting a tube. Tube production. Facing the tubes to length and comparing on the surface plate. Tubes fitted into firebox and smokebox tube plate. The tubes fitted with copper wire rings. The tube plate is used to keep the tubes in place. I bent the 45% silver braze rod round a 1/2 inch bar to form rings to place around each tube. No applied braze here. This is a much nicer way. 5 rings in place. Fluxed up with a lot of flux. You can't have too much. The immediate aftermath. The job is cooling down. I wait until quite cool before placing in a citric acid bath. Quite a few fire hazards next to the brazing hearth. Some shots of the still cooling down brazed joints. close-up inspection after pickling in acid, and back on the workbench. Good through-flow fillets on the inside of the firebox too. With the inner firebox fitted, it's time to align the tubes. Here I am clocking the tubes level prior to brazing in the smokebox tube plate. A little twisting was required to get them level. Next it was time to check that the backhead regulator bush would line up with the smokebox regulator bush. I made a tool from a 3/8 diameter bar with a 1/2 inch collar on one end and a 3/16 by 40 TPI thread on the other. There's a hole in the end to take a piece of piano wire to aid in aligning the tool. This tool mimics the proposed regulator assembly. I took a break from boiler work and mocked up a firehole door using offset hinges. The door on the quarry Hunslet uses a counterweight to keep it shut. The backhead fully populated with bushes, all brazed with a 34% silver braze. Here's the inner firebox test fitted into the boiler shell. The smokebox tube plate with coils of 45% silver braze for all the joints to be brazed in one go. Tubes all brazed. The central one needed redoing. I hadn't got it all hot enough. The manifold is in too. Getting ready to braze the backhead into the wrapper. I tried forming a rod of the 45% silver braze. I cut it into 3 pieces to get it to fit. Braze was directly applied too, and the scratch stick used to encourage the braze to flow, all the while being very careful not to overheat. The brazing operations were carried out with these side pieces fitted loosely to ensure the inner and outer fireboxes were correctly aligned. Those 2 brass screws were retained to keep the wrapper tight, but were destined to be brazed in. I'm checking that the firebox is aligned with the frames before brazing the backhead on. The copper sheet is no longer fully straight. I must have inadvertently bent it in the bench vise. These loosely placed rivets brazed in nicely. The hole was countersunk. The rivet will be snipped off. Here's the unfortunately brazed brass screw. It's bound to be constantly bathed in water in this position, so it'll have to be drilled out and replaced with a copper rivet and brazed again. Here's the only rivet that failed to be brazed. The copper rivets had all been fluxed, and I was hoping for through-hole brazing to occur. The rivet was loose and was later refluxed and brazed again. The brazed-in backhead. Braze was applied directly to the firehole ring. Look at that perfect fillet around the hole. More on this later. It's time to cut the footplate to allow the firebox to pass through. Straight on with the firehole door. It needs to be without a latch and supported by the lower bushes. There's a nail being used as a pivot. Offset hinges were made to positively close the door. The door is 1.6mm steel sheet and the hinges 0.6mm, held together with 10BA screws. That's quite an offset. I'm just gauging how things will go. Just about to drill through the fabricated brass hinge bracket for the door spindle on the bench drill powered Unimat 3 lathe. Centre punched and marked out, ready for drilling for the boiler bush screw and radiusing by filing. One side done. Making the second hinge bracket. I hand cut the slot for the sheet with the junior hacksaw and then filed with a needle file to get the 1.2mm width for the sheet thickness. After the brazing and the drilling, it was time to radius the end. I use a 3/8 rod with a 3/16 step turned as a filing guide. I'm using short stub axles instead of a one-piece, so that coal can easily fall through and not get caught up in the door. I made a sketch of the hinge brackets in case I needed to modify the dimensions. Here I put the firehole door through its paces. Starting on the boiler stays. I needed a drill extender to reach the throat plate. I used a piece of 3/8 steel rod, drilled 1/8 for the BS1 center drill. This was coated in Loctite 609 and aligned with the tailstock drill chuck and left overnight to cure. This is the setup. The humble bench drill needed extending too. The hole locations were center punched and then centre drilled, and then drilled through 1.5mm before opening out to 1/8 inch. Both ends of the drill extender were used. Set up to drill the backhead with the 1/8 drill. It was rigid enough. The copper sheets were always supported with timber packing pieces when drilling. Three stay holes were drilled front and back for 1/8 inch quarter rivets, with heads removed. No mathematical formulae were used, just rule of thumb estimation. This is a 40 psi boiler. You can see one stay in place with a coil of 1mm diameter silver braze wrapped around it, like a spring. This is the technique I used. The stays don't protrude much. The braze will mainly be on the inside. The 6 stays were carefully brazed in one go. When the job was hot enough, the flame was directly applied to them, and the braze flowed well. Now it's the time for the side stays. These were easy to drill. My greatest innovation. Using refractory paper to keep the heat off the backhead and the tube plate. It worked. Using wire clips to hold it in place. I braze these side stays 2 at a time, one level at a time, starting at the top of the boiler, the most difficult ones due to the depth. I needed my close reading spectacles for watching the braze flow. 1 level per day was achieved. You can't rush these things. Working my way up towards the bottom of the firebox. This was my fluxing technique, using a 1mm syringe with silicone tube to deliver flux to the stay between the copper sheets. The steel piece on the left with the circular cutout was used to press the coil of silver braze down to the stay hole before pushing the stay through it. The collet on the right was for holding the rivets for trimming them down to use as stays. Here are the stays all brazed. The round heads were retained on the upper sides. The lower needs to pass through the loco frames. I intend to clad the outer firebox. Now to complete the foundation ring. These end pieces are a complicated shape, lots of filing and fitting. Corner radii and slight tapers to file, and they have to remain in place during brazing. Those little holes were each filled with a snipped shard of copper sheet. Here we are, all ready to go. Liberally fluxed with strips of silver braze, just before the first of many heatings. The molten silver braze was spread around using my scratch stick on its side. I used the largest Siebert burner for this, for gentle heating, the mighty 2944 burner, keeping a close eye on not overheating all the previous work. It's quite a concern. The first leak test with not even a boiler full of water. The area was later fluxed up and rebrazed with more silver solder. A new leak in another area. It's easy to be continually chasing leaks, as each heating can cause the braze to change. It's important to flux all over regardless. Here I am applying pressure for the first time, and finding a leak in the regulator blanking plug. This plug will become the regulator body eventually. It needed proper sealing. I subsequently used white RTV sealant. You can see the large blobs of excess silver braze that has run down from the foundation ring, as I was a bit too liberal. I made a batch of boiler testing plugs, as I didn't have enough. These use an O-ring, so sealant isn't required. Previously I spent a lot of time applying PTFE plumber's tape, only to have to reapply it after another brazing operation. These O-ring types are only good for 40 psi. After that, excessive tightening is required. So eventually I went to using Loctite 542 thread sealant, which is excellent. Here's the firebox dome brazed on. It was the last major brazing job, using a whole ring of braze around its base. The holes needed aligning with the boiler, and its verticality checking against the dome. Here the lid is screwed on with plenty of RTV. Here's my initial setup with a trusty 0 to 86 psi gauge. Many adapters used to get it down to 3/16 by 40 thread. For fun, here's my first pump pressurizing attempt. 2 different sized pieces of silicone tube fitted nicely, and they accepted the good old filler. Why not? 2 findings. The pump valve is leaky, and the connection was only good for 10 psi. After that, myself and workshop were covered in a fountain of water. The good old valve from the large De Winton was fitted. This is the one that showered me with a fountain when I removed the pump from it at 10 psi. For proper hydro testing, the steam dome needs its cover making. The cover is a brass disc with a turned step to fit the hole, and with 6 holes for 8 BA screws. Here I am about to drill the first hole 1.8 mm for tapping. Then the cover is fixed with a screw for the remaining holes to be drilled and tapped. The cover was later drilled and tapped for the Goodall valve. At considerable pressure, here's the troublesome pinhole leak from the once perfect firehole ring fillet. It's very minor. I shall seal it with tap water. I did this with the quarry Hunslet. The minerals in the water will eventually plug it. Another minor leak that will receive the tap water treatment. The gauge in action at 40 psi. A pressure test at 80 psi. The pressure was incrementally worked up to 80 psi over time, with releasing of pressure and then repressurizing. The pressure cycling helping the copper to work harden. One minor leak that became apparent was one of the inner lower side stay joints. This was rebrazed successfully. Worth mentioning is the boiler volume. Full to the brim with water is just over 600 ml. Next morning at 10:30. Two days later and there's still pressure. Again about 10 o'clock in the morning. Thanks for watching.